Okay, Assalamualaikum warahmatullahi wabarakatuh. We met again in this series of lecture. If we can recall, we're still in the topic of linear algebraic equation, in which we are trying to solve simultaneous equations using certain numerical methods to find the value of unknowns. So we have covered a grammar rule in the past, in previous lecture. So this time around, we will discuss about method of elimination as a numerical tool to solve linear algebraic equations. Okay, in a nutshell, or I think I should give you some overview about what is method of elimination. So basically, it consists of several methods such as knife Gauss elimination. We also have Gauss elimination with partial pivoting, and as well as Gauss Gauss elimination with scaling and pivoting. So there are basically three more um, three more what we call as subtopics under method of eliminations. Okay, so the method of eliminations um, is more versatile, in which it can cover more than three equations. If you can recall, Cramer's rule can only deal at most with three equations. It cannot solve the problems involving more than three equations. But for method of elimination, we can use this method to solve more than three equations. But from practical point of view, if we deal with more than three equations, the calculation step will be very laborious, very cumbersome. So we may not try using this method to solve more than three equations. Okay, so because we have to do this using our hands, so it will be a very messy process if we go beyond three equations. Okay, let us go to the first method of elimination, known as naive Gauss elimination. So there are two processes in these methods. First is we have to do forward eliminations of unknowns. Once we have completed this first step, then we proceed to back substitution. So this is the step in which we will know the value of the unknowns. Okay, so let us jump to the first example. All right, so we have here three simultaneous equations. So all of these equations are linear equations. So let us go to our Excel worksheet to see the demonstration of Naes Gauss elimination. Okay. All right. So this I write down again the equations in the given problem. Okay, we have here three equations. Okay, first of all, we have to convert this equation into matrix form. Okay, so we create this matrix. Right. So each number represents the coefficient of each unknowns of each equations. Okay, for example, in the first row here, we have 3 that belongs to x1, minus 0.1 belongs to x2, and minus 0.2 belongs to x3. So and then the answer of each equation in this column. Okay, 7.85 minus 19.3 and 71.4. Okay, so once we have, okay, let me clear this up. Okay, so this is the matrix that we have created from the given equations, and this is the solution. Okay, sorry, this is the answer for each of the equation. So this column we write down the unknowns, right? X1, X2, and X3. Okay, first of all, okay, to start off, naive Gauss elimination, we have to make this figure. We have to make all these numbers. Okay, okay, all this number into 0. Okay, uh, okay. So um, we have to make all the numbers that I've highlighted in yellow become 0. So basically, all of these numbers are the numbers below these diagonal lines. Okay, right. So we have to turn each number, which is I highlighted in yellow, into 0. So how to do this is by okay, let us indicate this as row 1, row 2, and row 3. Okay, so in order to make all the numbers in yellow become 0, we have to do the summation between rows. Okay, for example, if we want to um, turn this number in row 2 into 0, we have to add row 1 and row 3 in a certain way. um, for example, if we um, divide row 1, okay, by 10, okay, row 1 by 10, and then add up row 1 and row 3 will become 0. Let me show to you. So we have R1 plus R3. Okay, become R3. So we have to uh, put a certain value of coefficient for row 1, so that when it adds up with row 3 becomes 0. And it's I mean 0.3, which is currently in row 3, becomes 0. So we need to divide row 1 by 10, okay, by minus 1 over 10. Okay. 1 over 10, okay. 1 over 10, row 1 plus, okay, minus 1 over 10, row 1 plus row 3 becomes row 3. So okay, so I will show to you. So now we have, so what is the resulting metric is, so we leave row 1 as it is because we are not changing anything on row 1. Also, we don't change anything on row 2 for the moment. 0.3. Okay, now we have to do something on row 3. Based on this first operation of summation, so for row 3, so minus 1 over 10 times row 1, so 3 times minus 1 over 10, it will give us minus 3. Okay, minus 3, and then we add with row 3, so sorry again, so 3 times minus 1 over 10 give us minus 0.3. So when we add this up, row 1 value with row 3, which is positive 0.3, we will get 0. Okay, so next we have to do this for each numbers in each column of row 3. So same thing here, so minus 0.1 times minus 1 over 10 plus minus 0.2. Okay, what I mean is, okay, this number times minus 1 over 10, and then plus row 3, which is minus 0.2. Okay, so we will get minus 0.19. Same thing here, times minus 1 over plus 10. Okay, and also here minus 1 over 3 plus sorry, this first row plus, okay, okay, so this is the new arrangement of matrix after we do this first um, operation. So remember, we want to make every individual number highlighted in yellow into 0. So we have done with the first one. So we want to change this 0.1 into 0, as well as this value minus 0.19 into 0. So next operation is I want to change this 0.1 into 0. So what I can do is so I will exploit the row 1 again. Um, hang on. So what I can do is okay, I can do something on row 1 and row 3. Okay, let us do something on row 1 and row 3. Sorry, row 2. Row 2. Okay, since I want to change this value of 0.1 into 0. Okay, so into row 2. So we need to multiply the row 1 with certain value of coefficient, so that when we add up with row 2, our 0.1 here becomes 0. So what I can do is uh, let's say 3 divided by 15. Okay, 30. So what I can do is I multiply the first row 30. Okay, so that when I multiply first row, okay, first number, for example here, this number over 30, one okay, again 1 over 30 times 3, we will get 0.1. Put it minus here. So 1 over 30 times 3, we get minus 0.1. So when we add up with row 2, so this 0.1 becomes 0. Okay, let us try. So we don't change anything for the values in row 1. Okay, let me divide this so that this is our row 1, this is our row 2, row 3, row 3. Okay, so we will change these row 2 values according to this operation. Okay, so becomes minus 1 over 30 times row 1 is 3. Okay, plus row 2 here. Okay. See, now it turns 0. So we do the same thing for other values. Okay, here minus 1 over 3 times row 1 here, okay, times plus 7, give us, or I should, so I should select this instead. Okay, okay, also same thing happen here. See, okay, and also for the answer for this row. Okay, you see, double check. So minus 1 over 30 times row 1, okay, minus 1 over 30 times row 1 plus row 2, sorry, times again 1 minus 1 over 30 times row 1, okay, plus row 2. Okay, so we don't change anything for the value in row 3. Okay, all right, so far we have already mixed these two set values into 0. Okay, 1 0.1 and 0.3 into 0. So we are only left with this final value, okay, in order to complete our forward elimination process. So we have to change this into 0. So we can again make use of row 1 so that we can modify the value of row 1 so that when we add up with row 3, this becomes 0. So we have to somehow put a certain value of coefficient so that when multiplied by 0.1 in row 1 and we add up with minus 0.119 in row 2, this value becomes 0. Okay, so let us see. Okay, so the solution is we have to multiply row 1 with coefficient value of 1.9 positive 1.9, okay, then plus row 3. Okay, then we start off our next step. So we don't change anything for row 1. So row 1, row 2, row 3. Okay, so for here we follow. So we don't change anything on row 2 as well. Okay, let the values as they are. Okay, this is the one that we have to do the changes. So for row 3, so we have to 1.9 times row 1, okay, times row 1 plus row 3. Sorry, hang on. Okay. Sorry, this is F, not R1 that we have to change. Somehow we need to change. Let me R2. R2. So we have to assign a certain value of coefficient for R2 so that when it add up with R3, this value becomes 0. Okay, so let us find out what is the value of that coefficient. So this is the value that we are looking for. So it should be positive, okay, positive 1.1071 Okay, so we let's try. So here 0.02713 times rho 2, okay, 0.02713 times rho 2, which is will give us 0, okay, plus rho 3 is 0. Okay, follow this operation that we have set earlier, so this becomes 0. And same thing for the next. You see that this actually 0, okay, because it's very um, very small. The value very small is actually 0, so we can assume that this is 0, okay. um, for this one, um, 0.07271 times rho 2, okay, plus rho 2, okay, plus rho 3. Okay, so we got 0, we got 10, yeah, here. Okay, so from here, 0 point times rho 2 plus 70. Okay, so we got this value. Okay, so far we have turned everything in each number here, okay, below this diagonal line, which is I already highlighted in yellow here, becomes 0. So we can start doing our back, what we call as back substitution. Okay, back substitution. Okay, remember, these are the unknowns that we have to find out. Okay, so here we can start doing our back substitution. So actually, our so 10 point. So actually, I take this number. Okay, this is our um, sorry. This is actually our x3. Okay, so take directly the final value here, because here other cells are 0, so this is the only numbers that we have. So this is actually the value of, sorry, okay, 10.0 whatever. So it's actually our x3, okay, equals 70.08, actually this number, okay, actually the number. this number. So x3 is this number divided by 10. Okay, so it's 7. Okay, so once we have get this 0 value in our first and second column, this actually our 10x3 equals 70.08 and so on. Then we make the division, so we get x3 equals more or less 7. So for x2, so we look at row 2 here. If you notice that we are working backwards, that's why it's called back substitution. So for x2, so 7x2, okay, follow here, okay, minus 0.29333 x3, okay, equals minus 19.56. Okay, and before that, just now we have found the value of x3, so we simply substitute the value of x3 here with the known value that we have just found just now. Okay, now x equals x2, okay, equals minus 19.56, okay, plus, so I bring this value to the right hand side, 0.2933 times x3, 7. Okay, okay, so our x2 becomes minus 19.56 plus 0.2933 times 7, okay, divided by 7. Okay, so we get x2 more or less negative 2.5. Okay, and then similarly for x1, look at this first row here, so we get 3x1, okay, minus 0.1 x2, okay, x2 which is just now we got 2.5, okay, minus 0.2 times x3 which is 7. Okay, we got 7.85. So what is our x1? So we simply, so x1 comes 0.85 plus 7.2 times 7 minus 0.1 times 2.5, okay, divide by 3, so 3. Okay, so this is our answer. So x1 is 3, x2 equals to minus 2.5, and x3 equals to 7. You can verify my answer with using your own calculator. Okay, so I hope you understand my demonstration, and we will meet again in the next series of lecture. Um, Next time we'll discuss about Gauss elimination with um, partial uh, pivoting. So thank you for listening. Bye.